friends, today we are going to study about factoring. Now, in factoring class, we have so many types, but the first one is the common monomial factoring. The second one, which is the common binomial factoring, is not commonly used. This one is the most commonly used factoring. When we have all the factoring here, we know how to factor everything, and then we have this advanced factoring in which we are going to factor our algebra expressions completely. Then the first thing that you are going to do is to find if there is a common monomial factor. We remove that one and then we do the rest. If there is a difference in two perfect squares, or this one, or the quadratic trinomial. And this number 6 class is for advanced learners, because the sum and difference of perfect cubes, we have x cubed plus y cubed. We are going to factor that one, or x cubed minus y cubed. So this type 6 is actually an optional for you. Maybe this one is for grade 10 or for grade 11 or for pre-calculus. Okay, for this type 1, which is the most commonly used, and type 2, which we are going to discuss, they are almost the same. For the common monomial, we don't need to group them because this common monomial is usually composed of two terms, or a binomial or a trinomial. When you see 4 algebra expression of 4 terms, quadrinomials, think of the common binomial because we are going to group them into a pair of binomials. So that's why this common binomial is called grouping. And in this type 1 and type 2, that is, we need to remove or extract the greatest common factor. We have to remove that one, and then so we can factor the remaining, or maybe that is the answer already. For this difference in two perfect squares, this one is the easiest. And for this type 3, you should know how to get the square root, not only of the number but also of the letters or the variables. We know already for perfect squares we have square root of 1 is 1, 4, square root of 4 is 2, square root of 9 is 3. So this 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, they are all perfect squares and we can get their square root. And then we can apply this one. How about the variables? We have x squared, and then x to the 4th, we have x to the 6th, x to the 8th. We can apply this difference into perfect squares for that. Perfect square trinomials, we have this one in our complete factoring, solving quadratic equations by completing the square. Okay, we use this one, perfect square trinomials, and we'll learn there how to identify or look for a perfect square trinomials. And this is composed only of 3 terms because it's trinomials. The quadratic trinomial is, sometimes we resort to trial and error here. If the numerical coefficient of the x squared is not 1, say 2, 3, 4, 5, 6, then that is this, the general quadratic trinomial. We say quadratic trinomial. Okay? So, I'm going to erase this one class and we are going to study this highest common factor, or sometimes we usually call this one as greatest common factor. Now, how do we get the greatest common factor? we should study that one first before we proceed to the common monomial factoring or common binomial factoring. Okay, so let us find the highest common factor of these examples. Now, if you know how to write numbers in its prime factored form, that will be easy for you. What do you mean by prime factored form? We are going to break the number in which we have 2, 3, 5, 7, and 9 are the factors. Prime means we have a prime number. Those are prime numbers. So prime numbers, the factors of these prime numbers are only 1 and itself. So 8 is not prime because we have many factors for 8. 12 is not prime because we have so many factors for 12. 4, no. 6, no. 5, this is a prime number. Why do we call this a prime number? Because its factors are only 1 and itself 5. 1 times 5 only, no more. 7 is also prime. 3 is also prime. 12, no. They're called, if a number is not prime, it is called composite number. Now if we are going to break the 8, let us break the 8. So for 8, we have 2 times 2 times 2. We break 8 into 2 times 2. 4 times 2 is 8. So that one is for 8. 8, and then we put an A here. And can be either plus or minus. If you have already in factoring, you can have 8A plus or 8A minus the 12B. But here, we are just showing you how to get the highest common factor of the GCF. We are not yet factoring it. Okay, for 12, so that is start with 2 times 6, and 6 can be factor also again, and then we have 2 times 3. 2 times 2 is 4, times 3 is 12. All the numbers here are all prime numbers. 2, 2, 3. And then we put the B here. Then we will remove the number or the letter that is common to both of them. And that one is called the GCF, or the highest common factor. Okay, let's have the 2. The 2, we have the 2 and 8 here. Do you have a 2 in the other side? Yes, we have. Okay. So they are both common, the 2. So we have the 2 here. Okay, they are both common. Times. We have another 2 here. Okay. Do we have another 2 on the other side? Yes, we have another 2 here. So we'll write again another 2 here. Okay. Next 2. We have the third 2 here. But when we go here, we don't have the 2 here, so we don't write the 2 anymore here because the 2 is here for 8 only, but not on the 12. It's finished. Okay, so finished here. Now, what about the 3? The 3 is in 12B, but here we don't have the 3, so we don't write the 3 because 3 is only for 12B and not for 8. After that one, letters. So first we do the numbers and then the letters. We have an A here, but on the other side, we don't have the A, so we don't write A. We have B here, but on the left side, we don't have the B, so we don't write the A or the B. So our highest common factor is, we multiply 2 times 2, so our highest common factor is 4. This 4 is the number that we are going to extract from our expressions if we are going to factor that, and then close, open pairing, and then close pairing here. So let's have the letter B. Now for letter B, let us divide 4, mean the factors of 4, not 1 times 4. Okay. So we have 2 here times another 2 here. And what is the meaning of x squared? The meaning of x squared is we have 2x. X, that is times there, times x. We have 2x. So 4 is 2 times 2. And x squared is x and x. Alright. And 6xy. Okay, we divide 6 into prime factor form. We have 2 times 3 only. And x, you copy the x. There's nothing to break with the x because it's single x. And y here. Now let's find the HCF, the greatest common factor or the highest common factor. We have a 2 here. Do we have a 2 on the other side? Yes, you have a 2 here. Then you write the 2 here. Times. The 2 is here, but we don't have the 2 on the other side. So don't write the other 2. We have 3 here, but we don't have 3 here. So don't write the 3 here. We have an x here, and we have an x also there on the other side. So we write the x. We have another x here, but this x has been used already, so we cannot use that one. We have another x here? No, so we don't write another x here. What about y? Y is here, but we don't have the y here. Do we need to write that one here? No. So our HCF is 2 times x, or simply 2x. That is our highest common factor. The one that we are going to extract from this binomial here. Okay, letter C. First is the number. The 5 here is a prime. The 7 there is a prime number also. Now, do you have 5 there? No. You have 7 here? No. So, we don't have a number here. We don't have a number there. Alright, what about the C? There is a C here, one C, and there is another C there. So, the C is their all common factor. Highest common factor is C only. There is no number there. Or 1 if you want. Alright, letter D. We have always first look at the number class. Okay? The number. So we have the 3. Okay? It's the same. 3. You cannot break it anymore. The 12, if you want, you can break it. I'm not saying always to break it. If you know that the 3 is the factor, the common factor, then leave that one. I'm just showing this one for others to see if that becomes complicated. So this one is 2 here, times 2 is 4, times 3, and then we write the A. That's the 12A. Here, no, it's the same thing as A. If we write here 3A, it's the same. Right, the HCF here. Let's have the 3. Do you have a 3 here? Yes. Do you have a 3 on the other side? Yes, there is. So, we put the 3 here. No more? Okay, we don't write any number here anymore because we don't have a number here except 3 only. We don't have 2, we don't have 5, nothing. And then A, the letter. After the number, the letters. Okay, we have an A here. What about on the other side? Do you have an A? Yes, there is an A there. And A is common to these two expressions. So we write the A here, and that is our highest common factor. By the way, class, if you are going to do the other method, to get the number, the highest common number, you start with the lowest one, 8. Not with the 12, you start with the 8. You start with the 4 here, but you cannot have that one because that one is 6. You start with the 5, you start with the 3. When you have start, if you are going to start with the 3, then you know that the 12 has 3. 1, 3. So you have the 3 already there. You don't need to resort to this kind of breaking them into because it will just waste your time. So you're just going to have more examples of this one. Okay, we have letter E now. We have 18bc squared and 12b squared c. So start from the smaller number, and the smaller number is 12. This one is 18. So we know they are both even numbers. So we can extract some number there because they are both even numbers. Now let's have the complete factor of 12. What's a complete factor of 12? We have 1, can you see that 1, times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Okay. Let us erase the 1 because 1 times 12, okay, we have 12, 2, 6, 3, 4. These are the factors of 12. Let's start from the highest number here, or the smaller one of the two. Start with the 12. Do you have 12 and 18? Can you get 18 by multiplying 12 by a certain number? No. So 12 cannot be our common factor. Let's say the next one, the 6. We start going from highest to lowest. So 6. Do you have 6 and 18? Yes, because 18 divided by 6 is exactly 3. So we are going to choose this one. We are not going to test anymore the 2, the 3, and the 4 because we have the highest here, which is 6. So we remove this one. So the HCF here, we have a number common to both of them is the 6. Okay. Let's erase this one. Let's have the B. We have a B there. So we have one B here and we have two B's there. We have B and B. So choose the one that has the lowest exponent. Exponent of this one is 1. So you choose this one. So you write B because they have both B. But choose the lower exponent. So choose B to the first power. C squared. Do you have a C there? Yes. But the C here is to the first power. You choose that one and not this one. There are two here. There is only one there. And common to both of them is only one C. So we write C here and that is the highest common factor. Okay, letter F. We have 15, 20, and 30. We choose the smallest. And that is 15. Let us factor 15. 1, I'm not going to write anymore the 1. 1 times 15 is 15. And this one here, 15. Okay. Next is 2 times, no, we cannot get the 15 from 2. 3, yes, we have 3 times 5. What else? 4, no. 5, it's there already. 6, no. 7, 8, 9, 10, 11, no. So we factors 15, 15, 3, and 5. Start from the largest, from 15. 15, of course that's 15. 20, can we get 20 by multiplying 15 by a certain number? No. No, we can divide 20 by 15. 30, when it is no already, then finish. Cannot choose this one because we cannot divide 20 by 15. That is exact. So remove the 15. No, this one can't be. Right, the next higher number, not the lowest, not the smallest. We choose the 5. The last one will be the smallest. Let us take the 5. Can we divide? No problem here because the 5 is from the 15. Can we divide 20 by 5? Yes, it is 4. Can we divide 30 by 5? Yes, it is 6. Therefore, our HCF is the 5 here. Okay, we remove, extract the 5. Let's have the letters. We have an A here. We don't have the A there. We have the B here. We have the B there. But the problem is we don't have the B. So we don't write the B also. So the highest common factor of this trinomial, if you're going to factor this one, or 3 terms, we have 5 only. The one that is the highest common factor. Okay, let's have letter G. 24 and 36. Which is smaller? 24. So we start from the smaller. Alright, let's have the factor. 24. 1 times 24 is 24. We have 2 times 12 is 24. After the 2 is 3. 3 times 8 is 24. 4 times 6 is 24. 5 times, no, 6 is there already. 7, no, 8 is there already. 9, no, 10, 11, 12 is here. So these are the factors of 24. Where do we start? From the largest, which is 24. Look at 24 here. So can we divide 36 by 24? No. Okay, scratch this one. Let's go to the next higher number, which is 12. Okay, where is it? 12. Now, can we divide 36 by 12? Oh, yes. So we stop here and we don't mind any of the 3, 8, the 2, the 4, and the 6 because we can use the 12. Because 36 divided by 12 is 3. So let's have the HCF here. So we have 12. Okay. Now here we have p squared. We are lucky because this is only 2. We have the p here, but the p here class is p to the first. So you select this p to the first and not the p squared. So you write the p here. Okay. Q. Do you have a q there? Yes, this one is to the first. That one is to the first. So we select the q because q is both in them. R and R squared, well, which of the two are you going to choose? The R to the first. So just R, and this is our HCF. So our examples up to G is for the common monomial factoring. And for letter H, this one is different. This one is for the common binomial factoring, in which they are grouped already. We grouped and then it's factored already. We group them. We get the common monomial of this one. We get the common monomial of the other one. It's grouped already. Now, this one is considered as one term. This one is considered as one term. Do you see here, class, what's common? What's the same with this one and that one? Alright, do you have 5 here? No, we don't have. What is common to them? The common to them is, what's the HCF here? A binomial, not a monomial already, because this we have monomial, monomial, monomial. And here, we have the common, and we can see clearly the x plus 2 and the x plus 2, they are the same. And they are to the first power and to the first power. So that is our HCF, x plus 2. And if there's something following the x plus 2 or on the other side, you place it like this. So our highest common factor here is a binomial here. Now class, if this one is like this and the other one is 2 here, 2, you choose to the first because that one is the lowest. If this one is 2 here and that one is 3, then you choose to the second and you put here to the second power.